much. I will attempt to debug that at some point, probably not now, but possibly. Who can say?
Oops, wrong one.
It's the infinite screen.
Whoa! Yeah, let's not do that.
Too early for that.
Yeah, I think so. This is the one I wanted. There we go.
By the way, guys, I've already had one crash of the whole window frame. I was in the note-taking thing, so I'm now going to run it in a separate outside window. But just FYI, if you run into the same thing, it just crashed and I had to log back in. It took a second.
Okay. All right. Well, it's 9 o'clock, so since we're time constrained, I guess we'll get started. Leslie.
Yeah, it's 9 o'clock somewhere. All right. Thank you. This is the Media Ops Working Group. I assume everybody knows that since you elected to be here and it's not an anonymous room. Please note well, standard IETF policies apply. I'll give you a moment to digest that.
No, well, I'll leave it there for a little bit longer.
And while that's still there for another moment, I will say thank you everybody for coming along and joining us today. It's nice to see a healthy turnout for this working group session. I think we've got a lot of interesting stuff on the agenda, and we'll just have to keep, if we keep pressing forward, we're not trying to be rude, we're just trying to make sure that we get through a lot of material that we have. All right, next slide, please. Yes, as I said, we have a fairly healthy agenda right here. My suspicion is that by the end of this session, we may be identifying material for an interim before the IETF 109 meeting. And I'm going to say again, thank you to Glenn Dean for being our note taker, but please, anybody else who wants to keep an eye on the CodeEMD window and participate in helping edit the notes would also be appreciated. And thank you to Magnus Westerlund for being our Jabber scribe today. All right, I think that's it. Kyle, anything else?
I don't have anything, so I guess we can just go to the first agenda item.
Yeah.
Where is it?
All right, I will let Jake
there we go.
Speak and video. There we go.
Jake, do you want me to run the slides for you?
Yeah, that'd be great. Thanks.
Okay.
Okay, I'm Jake Holland. I'm giving an update on our streaming operational considerations draft. Spencer Dawkins and Ali have joined. Next slide, please. So I think we discussed it at the interim. There is now a session about COVID, a section about COVID that Spencer put in. We changed up the notes for contributors section and put it near the front where it's easier to find and read. We added the template we discussed for how to submit the issues. I have a slide on that at the end so you can see it. And the overall draft moved into its new home in the IETF WG MOPS. And thanks to Kyle for help with that. And actually the GH pages problem got fixed, I think, yesterday. So also
well,
thanks.
It's at least temporarily fixed.
Anyway, a few minor technical issues possibly, so just make sure to check the draft for now. Yeah, next slide, please. The open issues list is almost the same as last time, but I put in the links to the actual issue numbers. And we haven't closed a whole lot. I think some of the authors have been a little busy. And the new issues in the blue at the bottom here are just the new references, some updates to the references for the new COVID sec. It's actually named extremely unpredictable traffic patterns to go with the unpredictable traffic patterns. And the issue about the broken GH pages where the GitHub website for this is hosted. Next slide. So there's also a discussion we had about latency. Sorry, previous slide. There's one other point to state about the ads thing. There's a pending pull request from Matt Stock. Thank you. Some discussions on that. And we'll be putting something in there, we think, about the ads. Anyway, next slide. So there was a latency discussion on the issues in the issues tracker. It basically came up that there's some question about different streaming technologies. RTP was mentioned, RTMP, whether we should have a section that kind of outlines some pros and cons in the issues regarding latency. There were some scope questions about whether this is properly in scope for the working group. I think so. I added a link to the mail thread into the issues list, but I think there were a few questions left hanging on that point. So if we get a chance, it might be worth, I don't know, taking a hum on that. I think that Ollie had some notes that there might be something useful to say about it without stepping really out of bounds on, you know, providing guidance on use of RTP or anything. So I don't know what that would look like, but I think that I would suggest that we go ahead and move things forward and then take a look at it and review whether it looks properly in scope. There were a few, but the main point of the open scoping questions is whether we should say anything at all about things like Stadia, where there's you know, streaming of video games that relies on the video stream and has tight latency constraints, and whether conferencing with the sort of real-time back and forth should be brought up or mentioned as a point of do we differentiate on content? Yeah. So that's just a I think that it's maybe a minor point, but something that could bear some further discussion and making sure we're not stepping out of bounds on this. So yeah, next slide. I think I just have another. Yeah, please. Kyle?
Yeah, from Alexander Goulart. The question about Stadia was do we differentiate on content? Is there a difference between Twitch streaming game screen or game content being streamed directly?
So there's differences depending on the protocol that's in use, I think, is the way we're framing it, and sort of different use cases that have different requirements.
So Twitch streaming is really just consumption of video. It's like watching YouTube, except you're watching somebody game. It's not interactive in the same way that like Stadia would be.
There is some interactivity, I think, because you do have some back and forth discussion with the audience sometimes. But it's not really the same tight latency requirements.
Right. Yeah, that's what I was getting at.
Glenn, I think that was Alex. I think that was Alex. Yeah. Okay, so outside of the latency discussion, I just wanted to remind everyone that we would love to get a sort of list of issues that have been encountered as part of video streaming from people who've encountered them. Tell us about them. This is the template that we have. There was one minor update to it. I think the trade-offs mention because often it's trade-offs, but it's roughly what it looked like last time, but I don't think we've gotten anything in this template form yet. So I will send Spencer after you if you don't send something in. He'll be super nice at you. And yeah, I guess that's all I've got. So do we want to have the latency discussion now, or just a exhortation to please consider it and send something to the list?
I think that we need to, I don't think we have the time to have it today. I mean, I recognize that it's an issue that's been kicking around for a couple of months. But what I think I would like to do, and Kyle, jump in if you think this is, if you'd like to handle it differently. What I think I would like to do is say, let's frame up the discussion as an agenda item, either on an interim or on the next regular meeting. And I think that your notion of trying to start writing some stuff up so that we actually have material to consider and aren't just thumb wrestling over our experiences with particular technologies is probably the best plan. Does that make sense to you, Kyle?
Yeah, I think definitely having something teed up for a discussion at the next interim would be a good idea. I think we should probably not wait 4 months to the next meeting. So yeah. If Jake, if you can throw something together, we'll figure out some time to hold an interim well before IETF 109.
And it's not necessarily throwing something together to compare and contrast what might or might not be in, but what I heard you say in your commentary was...
Lost you, Leslie.
You got super quiet there, Leslie. Not necessarily...
She probably can't hear us. She might have pulled her microphone slightly out of the jack. I'm just texting her side channel, so. Oh, technology. How many engineers does it take?
I'm not sure about this whole man.
All right. So nothing.
Okay. Yeah. So Leslie's gonna figure that out. But in the meantime, I can't remember what we were saying. What was the what was Leslie saying?
She
Which
said,
disappeared.
Something not necessarily. She was agreeing that we should write something up, and not necessarily about having a thumb wrestling match over what's there, but. I think she was going to give some helpful advice there that I think it makes we're including it. Okay.
Yeah, I think it makes sense to have some proposed content, and then we can refine it, help refine it at the meeting, rather than trying to have a meeting where we like a composition meeting, which might not be super productive.
Any are you still on the don't check it in, or can we check it in and pull it out after? Does it matter?
I mean, I think so. If you put it into, that's a good question, right? Because there are people who don't. Yeah, we'll figure it out.
Okay.
Yeah.
Yep. All right. I guess that's it then.
All right. Great. Okay, we're gonna move on now. Thank you, Jake. Any other questions, actually?
Oh yeah.
Is there anybody in the queue? Doesn't look like it. Oh, Leslie's back. Did you want to add anything?
Can you hear me? Still not here?
No, it's not looking good.
I
Okay. All right. Let's move on since we're kind of time constrained. So thank you, Jake.
How do I get out of this?
Click the camera icon to stop video. Yeah, there you go.
And,
All right, so next up on the agenda is Chris Kulbakis, and he'll be talking about best practices for end-to-end workflow monitoring from the Streaming Video Alliance. Oh, I have to stop my screen share. There we go. And you're up.
Hear me? Hello?
I can see your screen. Can you
Okay.
can you hear me? Okay.
Yes, I can.
No, apparently not.
Okay, I can hear you now, Leslie. Oh.
Different microphone.
Yeah, you're still a little quiet, but at least I can hear
Yeah,
you.
it's going to be quiet because it's a different microphone. Although I will note two things. One, exactly nothing changed. I'm sitting here with my headphones plugged into the computer, and audio failed on the Meet Echo, and I can see the little nice VU bars bouncing up and down, and it even says I'm, filling the. I'm at risk of clipping for how loud I'm talking right now. But anyway, we'll file a bug report afterwards.
You sound good at the moment. So anyway, so Christopher, you want to continue?
Yep. Can you hear me? Hello?
Can hear you. Uh-oh. Hopefully he can hear us. Dope.
Okay. I can hear you. Can you hear me?
Well, actually, I don't even know if he's in the chat, but yes, we can hear you.
Okay, perfect. So, okay. So I'll start. Okay, so hi everyone. My name is Chris Kulbakis. It is my pleasure and an honor to be here and present at the IETF108, and thank you very much for having me here. Today I will provide a quick status update and an overview of the best practices for end-to-end workflow monitoring project. This project is being worked on by the Streaming Video Alliance as part of the Measurement Quality of Experience work group. Just a little bit of background about myself. I've been a member of the SVA since 2018, mainly focusing on measurement and quality of experience and its applicability to live streaming and advertising. I've also spent the last 10 years in the video monitoring space, the first 7 at Rogers Communications, a Canadian operator, as a technical lead building end-to-end digital TV and IPTV video monitoring systems. And most recently, I spent 3 years at SimWave, a Canadian perceptual video quality measurement startup, in a technical product role. So a quick glance at the agenda. I would like to take the next 15 minutes to just go through the contributors to the project, the industry motivation for the project, goals of the project, the QoE definition adopted by the project scope, a quick overview of the proposed framework, followed by an example application of the framework, and finishing with an outage detection example using the framework approach. And then finishing off with a 5-minute Q&A. So, the project was born out of the industry's need for a systematic and a comprehensive approach for real-time video streaming monitoring. As such, this project's contributing companies, along with the rest of the SVA membership, comprise a representative mix of video workflow stakeholders, including content owners, for example, Disney, service operators, for example, Sky, and now Disney as well, with Disney Plus, for instance, and vendors specializing in quality measurement for video streaming, including DataZoom, Opticom, SimWave, Telestream, and TouchStream. Thomas Edwards is the Measurement QoE Workgroup Chair, and myself, along with Brenton O of TouchStreams, are the 2 project co-leads. The document is currently undergoing an SVA review process, and the plan is to publish in Q3 of this year. So what we're seeing is that the industry continues to have a need for a comprehensive end-to-end video monitoring framework. For media operations and NOC teams, this is especially important as they need to be able to proactively detect failures or degradations and efficiently carry out customer impact assessment, workflow fault isolation, and root cause analysis in order to reduce mean time to detection and mean time to resolution. Similarly, engineering and technology groups need to be able to measure system performance and establish perceptual quality trends in order to characterize and optimize workflows. However, to this day, these diagnostic and measurement activities can be extremely challenging for the media operations teams. To illustrate, here we're showing a prototypical end-to-end video streaming workflow view. We use this view in the best practices doc. It is a very high-level view. It omits a lot of complexity. However, it does focus on the key video workflow functions and video transformations. From left to right, we have source production, which feeds into encoding. Then we have transcoding, packaging, origin, content delivery network, and customer premises equipment, such as phones, tablets, browsers, set-top boxes, connected devices, etc. So for instance, when a customer is experiencing an issue, such as a frozen screen, teams need to quickly qualify primarily where in the workflow has the failure occurred. For example, is it the customer environment, the delivery, the content processing, or even the source? And secondly, what is the scope of impact on the customer population? Is it a single device, a single household, single region, multiple regions, or even an entire subscriber base? And in general, it is not straightforward to establish the scope, nature, and the root cause of video service impacts. In many outage or degradation scenarios, it's not sufficient, for example, to only instrument the player or the CPE, or to only rely on CDN probes or CDN logs for video quality information. In the following example, suppose we want to know the quality that each of our subscribers is receiving. So we've instrumented the players. So we're getting metrics such as video startup time, rebuffering ratio, average media bitrate, video start failure. And they're all showing okay, they're all showing green. And we've also instrumented the CDN and the origin, and we're getting metrics such as availability, response time, bitrate for both manifests and chunks. And again, they're all green, they're all showing okay. Everything seems fine and metric-wise from these three monitoring points. However, the end viewer is getting a frozen screen. So one potential scenario that makes this possible is as follows. The source can fail, the encoder loses input. However, the encoder does continue to generate a well-formed video stream output with non-changing pixels. And the rest of the chain doesn't know any better and is happy to deliver the content along and play it out for the viewer, and resulting in a frozen screen to the customer. So source degradation or failure is just one of many potential root causes that can result in a bad video being consumed by the end viewer. This next example shows how video quality degradation may not even occur on the network or transport layer altogether. Instead, it can occur on the content layer itself. So similar to the previous example, we're monitoring our players and our delivery at CDN and origin. These metrics show healthy delivery and playout. Metric measurements are within okay ranges in green. However, the end viewer again is receiving poor perceptual video quality. For example, it's not as sharp, it's fuzzy, blocky. So in this example, we're receiving a pristine source. However, the encoder is too aggressive. It overcompresses the video, but still produces a well-formed video stream again. Again, the rest of the chain doesn't know any better and is happy to push the content along and play it out. Again, the end viewer ends up with poor video quality. The previous example showed that network layer monitoring is not sufficient either. In other words, we also need content level monitoring. This third example shows another interesting property of video workflows. Video workflows can regenerate transport layer packets. This is another reason why video workflow issues are difficult to diagnose. In this example, again, player and delivery metrics show a healthy video stream. However, the video quality that the viewer is receiving is unwatchable, such as pixelating video and choppy audio. So in this example, we're receiving a pristine source, and the encoder actually does a great job with compression. However, we have packet loss in the network segment post-encode output. But since the packet loss is not high enough, then transcoder still continues the transcode process and produces a well-formed stream. This video stream, although well-formed, is missing some video content information. However, the rest of the chain does not know any better, and the result is bad video quality to the end viewer. In general, many underlying factors can contribute to poor customer viewing experience, not just the examples mentioned above. Different root causes at different parts in the workflow can introduce different impacts. Different source issues, such as poor source quality, different content processing issues affecting encoding, transcoding, and packaging, such as poor encode quality, packet losses or jitter, poor transcode quality, EBP IDR not aligning properly, DRM issues, etc. Different publishing issues affecting the origin, such as ingestion, replication, and hosting issues, as well as different distribution issues affecting the origin CDN, the internet, the last mile, and different playout issues, such as the home environment and device issues, including Wi-Fi, device, player, SDK, and even usage. All these factors can contribute to bad viewer quality, not to mention other aspects that can also contribute to bad user experience, including latency, advertising, compliance, loudness, cloud issues, the list goes on and on. Another complication is that the resulting end viewer quality of experience in general is a confluence or a mix of multiple unrelated issues. As these impacts occur along the workflow, they propagate downstream and they mix together, making it difficult for media operations teams to isolate the different issues, delineate workflow areas at fault, and identify root causes. Moreover, the impact is not necessarily the same for every viewer. Different viewers may be experiencing different quality impacts depending on where they are geographically, what device they are using, and what assets they are watching. In this illustrative example, the resulting consumer impact is due to several root causes, each root cause contributing its own quality impact. Picture macroblocking is introduced at source due to packet loss. Picture is losing sharpness at the encoder due to overcompression. Ringing noise is being introduced into the picture on content level at the transcode. Top profile went into outage at the packager, and just latency spikes at the origin are causing jitter in distribution. CD and edge cache failure is causing unavailability in a specific region, and a bug in latest firmware of the player is causing intermittent playback issues for a particular type of device. So based on this motivation, the project goals are to create best practices on implementing a system to capture QoE and other measurement data at each monitoring point across the workflow, identify streaming video metrics to gather at each monitoring point, establish guidelines on how to calculate or leverage existing metrics at each monitoring point, and investigate potential for an end-to-end metric or metrics across all monitoring points. So the project adopts the ITUT definition of QoE. Essentially, as we saw in the motivation section, any issue impacting the workflow at any point in that workflow has the potential to impact the degree of delight or annoyance of the user of an application or a service. In the best practices document, we're not attempting to define a single QoE metric. Instead, we're focusing on different monitoring methods and the different monitoring metrics that are available, and how these can be used in concert to achieve an end-to-end monitoring framework. So the scope of the project is IPTV OTT systems, focuses on live workflows. The scope is end-to-end from source suggestion to device output and playout. The framework can be applied to both cloud-based and on-premise-based workflows, including hybrid workflows. And the monitoring is geared towards operational use cases, for example, detection and delineation of issues. The monitoring instrumentation is also focused on probes, logs, and player APIs. So for example, application performance monitoring solutions are not considered in this framework. For example, node CPU load or memory utilization or temperature, etc. So the best practices doc proposes an end-to-end monitoring framework as follows. Firstly, establish an end-to-end scope for monitoring of a service, for example, from sources through to device output. Secondly, decompose the end-to-end monitoring scope into monitoring points. For example, sources input, encoder output, transcoder output, packager output, origin output, CDN output, player output, device output. Then decompose each monitoring point into measurement layers. Content, for example, the video encode quality itself. The envelope, for example, the network and transport performance and availability metrics. Auxiliary, for example, any other relevant monitoring information such as DRM, subsystem encryption, key exchange status, authentication, subsystem health and statistics, and status of logins of subscribers, and player playout error and error messages, for instance. Fourth, for each monitoring point and for each measurement layer, describe where is the monitoring taking place. For example, is it at the source on premises? Is it post-transcode in the cloud? What is being monitored exactly? For example, is it the video content itself, or is it the MPEG to transport stream packet headers, or is it the IP packet headers, for example? How is the monitoring carried out? For example, whether you're using a physical splitter or a sniffer or a tap, or is it a network IGMP join, or is it HTTP GET, or is it a player SDK API, or even a device HDMI output? And why is the monitoring being done at the particular monitoring point? For example, is it for junk in, junk out source monitoring to establish a baseline? Is it to quantify encoder compression impact, etc.? And fifth, as a last step, aggregate individual monitoring point results with the end-to-end approach in mind. First on a per monitoring point basis, then on a subsystem scope, for example, source, processing, publishing, delivery, playout, and finally across the entire end-to-end scope. So the following is an example of a framework application for an OTT service operator. In this case, the operator receives high bitrate compressed mezzanine source from a third-party content owner. The operator transcodes and packages the content, and then sends the packaged content downstream to a third-party CDN provider. The third-party CDN hosts and distributes the content, and once the content is distributed, the viewers consume the content using the operator's devices and players. So with respect to monitoring, since the framework is modular in nature, we can choose which monitoring points to deploy, given the monitoring needs and constraints. In this example, since the operator does not own the upstream encoder, therefore encoder output, aka transcoder input, is monitoring point 1. Here, using IGMP join to the output of the encoder, the operator uses a probe for both the video content and the network and transport layers, IPUDP and P2TS, for example, are being monitored. Since the operator owns the transcoder, hence the transcoder output is monitoring point 2, and similar to monitoring point 1, also measures content and network delivery quality using probes. This is done for all multi-bitrate profiles. Since the operator owns the packager, hence packager output is monitoring point 3. Here, the operator uses probes using HTTP GET in order to measure various IP, TCP, HTTP, and HLS manifest and chunk network metrics. As with the transcoder, all adaptive bitrate profiles are monitored. The content quality is not measured at the packager output, as the content is encrypted by the packager. Since the operator also owns the device and the player, hence the operator collects player data, for example, playout events and errors, using the player API, making it monitoring point 4. It's also worth noting that at the player, we do not monitor content nor the network directly. We are limited to what the player API can provide. We are also constrained by the compute resource of the consumer device. So in summary, the best practices document presents various options as to how one can define a high-level end-to-end monitoring approach, the different monitoring points, different monitoring layers, and the different monitoring options, including purpose, advantages, disadvantages, methods, and metrics. As a last slide today, this next example shows an outage detection using an 8-point monitoring application of the framework. In this case, let's suppose that we have a video macroblocking consumer impact. As was described in an example at the beginning of this presentation, this is the case where the source was coming in clean and the macroblocking was introduced post-encoder due to packet loss. Hence, monitoring-wise, since the source is coming in fine, our content and network level metrics show a healthy source. However, at the encode output, we do detect impact on both content and network layers. For example, our video QoE algorithms show dipping scores, and for example, our network metrics indicate packet loss or signal loss. Working downstream content-wise, our QoE algorithm shows impact at transcoder output as well. However, again, since the packager encrypts the content, thus we cannot measure content quality across the delivery, including at the player. Nonetheless, even though the content is encrypted, we can still monitor network delivery. In this example, transcoder output does not show any network level issues, as the transcoder regenerates the IPUDP and P2TS stack. Similarly, the packager and the ABR content delivery, for example, IPTCP, HTTP, HLS stack metrics do not show any issues. The downstream player is also happy to play the
just a brief reminder, you've got about 4.5 minutes left, and that includes time for questions.
Okay, thank you. So the downstream player is also happy to play the content out with good startup time, no rebuffering, and the highest quality profile being played out. All player event metrics look good. No errors are coming in from players as well. However, post-device, once again, we do detect perceptual picture breakup with QoE algorithm on content level. So that concludes the presentation, and thank you very much. And this is the Q&A section. Thank you.
All right, thanks, Chris. So anyone have any questions? I guess you click on the microphone hand icon to get in the queue. Any questions? No? Oh. Leslie?
Yeah, so maybe not a question so much as a comment. one of the reasons why I thought this was really interesting work to have here was because it really does show the spread of all the things that need to go right in order for video to work well. And I think that I think everyone understands that at a certain intellectual level, but having it sort of spread out here and sort of compartmentalized into the different steps, I think is really useful. And as you said, Chris, this is all about what the SVA is working on in terms of how to measure stuff and how to a framework for looking at how to, rate the quality of experience or detect issues with quality of experience and impacts downstream from problems upstream. So I think that there's a lot of interesting stuff here that's more than one can get to in a 15-minute presentation, wonderful though it was. Approximately when do you think the SVA document is actually going to be published and publicly consumable?
Yep. So this should happen imminently in Q3, most likely. It's already been reviewed by the membership, and now it's being reviewed by the board. And afterwards, we will make any remaining updates that are required, and then the document will be published. So Q3, most likely.
All right. Glenn?
Can you hear me?
Yes.
So, one of the things, Chris, that strikes me, and this is sort of a broad question for you, is that, this presentation did do a great view of sort of application and encoding, delivery, all those pieces that come together end to end to make it work. One of the things that you guys didn't think of, but I think maybe of interest to the future here at the IETF, is the layer just below that stuff, which is the network layer, because a lot of these pieces I note, some of them go over well-managed networks. That means like the video production team might be able to manage their own network, but a whole bunch of other pieces of this go over unmanaged networks, the open internet, and that's always difficult to understand from an algorithmic perspective in the player. I'm wondering if there's potentially future work where we look at how do you connect that higher level stuff and give it awareness of what it sees and what's behaving on the open internet and other networks, of course, so that it can better, inform people trying to fix the problem, but also maybe algorithmically be able to respond to it more dynamically. And I'm not even sure how I'm going to answer my own question in the notes, but I'll do my best or capture it.
That's thank you, Glenda. Yeah, that's so. For example, this slide here shows the service operator example, and in this case, I mean, this could be a managed network, but this could also be an unmanaged network. And as you can see here, the service operator has third parties providing the sources, and also has third parties providing the origin and CDN functionality. So, and in this case, this could be an OTT streaming service operator, and the third-party sources, for example, could be coming in to the operator's transcoders over the open internet. And also similarly, downstream, the service operator could be providing the packaged HLS content to the third-party CDN provider, again, over the internet to the cloud. So, these types of deployment patterns here, could speak to also unmanaged, end-to-end unmanaged video services, including, hybrid video services, partly on premises, partly on cloud, as well as, composed of multiple stakeholders, third parties providing different components and content, etc. So there are definitely, also, the internet could be interspersed anywhere here along these workflow stages. And yes, absolutely, in terms of the monitoring work that we're working on, it also speaks to the network and transport layers, not just the application layer, not just the content layer. All of these layers, what we're trying to say is that all of these layers need to be systematically monitored all the way from content application through to transport and network.
All right, I think we're just about out of time. Thank you, Chris. Is there anything that if people want to follow up with you, how should they get in contact with you?
Yeah, absolutely. What I can do is just provide my email at the end. It's christopher.kulbakis@gmail.com. And I can provide my contact information afterwards.
All right, thank you.
Thank you.
And up next is Alexander Goulard. And it looks like, so can you hear me, Alexander?
Yeah.
Okay. I don't have your, I don't see your screen quite yet. Yeah, there we go. Although,
there you go.
Yes.
Can you hear me?
Perfect. Yes, can hear you just fine.
All right. I only have 5 minutes left, so.
Hang on. These slides are not posted in the meeting materials. Is that correct?
I shared them with you specifically, as you asked yesterday.
Okay. All right.
And
Then I will
okay.
work on.
It looks like your name is not there, so I might have missed that. But I thought I had shared them with you yesterday. I will share them right away if you
Okay.
want. I mean,
Yes,
Yes,
because-
we'll add them to the meeting materials right after the meeting. Apologies for everyone who was following along at home.
If I have them in my inbox, I can be uploading them during the meeting for anybody who is not.
Right. I mean, so I wrote those slides to be a basis for discussion. So it's a good material for reading and discussing later on the mailing list. A little bit less to present, so I can maybe make it a little bit faster when I present. First is a disclaimer. I didn't spend a lot of time on it, not enough to make it a real conclusion or anything. So anything here is just a list of questions and opinion, and to check my understanding and to check that what we want to achieve through the test of different protocol as it was proposed. There are a few questions when it comes to be able to be fair and to be informative, right? We need to be able to have a good basis for comparison and reproducible tests, so people do not trust me and do not trust anyone and do the thing by themselves again and are able to reproduce the result we're gonna reach. And sometimes fairness is it doesn't matter, even if you know a comparison is not exactly fair between HLS and RTMP, for example, which is not one of the things we're gonna do, but I take as an example, you still are interested in certain condition about the result and the data, right? So some of the tests we're going to do are not going to be fair, but might be interesting for the community. And I'd like the direction from the chair and from the group about which question are of interest eventually if we go there. So a small little problem to have a strong base for comparison is to know what we're testing, right? To make sure that we're not testing a moving target and that the day after we finish testing, it just updated and there is a new feature and you need to do everything again. So there is a little slight concern about the versioning of SRT, but this is not a big concern and that can be worked with the team there. My biggest concern really to make a fair comparison is what to compare SRT or RTMP and other with. Is it a fair comparison? If I take HLS, for example, right, which is a stack, you have HLS, HTTPS, then HTTP, then go down to TCP. Would it be fair to compare HLS with HTTPS? I don't think that's the case, but they don't exactly do the same thing. So is SRT a transport or a media transport? And the example I'm giving here, the definition is a transport is something that is not specific to media. It can transport media, but it can also transport other stuff. And it doesn't have anything that is media specific. Just like you can put media in HTTPS, but you're not reaching HLS, right? HLS will have all this information about the number of tracks, the type of the tracks, which codec was used, is there subtitle, and so on and so forth. That comes on top of HTTPS. And so comparing them directly like this is difficult. So we see a lot of non-media transport being used nowadays to transport media. I could cite WebSocket, for example. And so the question is it a fair comparison, number one? And number two, is it a comparison we want to do anyway, right? Because people use it that way, so people are interested in knowing what is the most appropriate when it comes to transporting media, and what are the trade-off in between those different protocols, whether they are a dedicated media protocol like RTP or not really, like QUIC by default, right? Is it still interesting to use QUIC directly? So there is a lot of different angle to that question that are better read and discussed on the mailing list after. There's actually 3 slides of them to try to be as thorough as possible. Then the question is, which features do we want to test? I think I saw a lot of documents that were describing SRT advantage over RTMP on the different features. So I think those should be included, if only to show the contrast between SRT and RTMP. Reliability, is it full reliability, no reliability, partial reliability? And depending on the layer, again, right, is the reliability coming from the transport? Are you using TCP? Or is the partial reliability coming from the media protocol, like in the case of RTP? The resilience to network condition, the security, however hard it is to test, and firewall NAT traversal are 4 points that I think should be tested to a certain extent. I might be missing other points that are important, and here I'm welcoming feedback from the group to tell me what they think would be of interest. I think it's also important here again to show where the reliability, resilience, security, or firewall traversal capacity comes from in the OZ layer decomposition, because you could then make have a better understanding of the choice between 2 stacks that share the same underlying layer. Finally, I think there's something we don't speak about too much, but that's the global use case. I think the previous presentation did a very good job to show that the delivery of the media in streaming from the source to the viewer has a lot of steps. And I don't think there is a single protocol that is used for every single one of them, right? So my understanding from outside is that SRT or TMP today, and sometimes WebRTC, are used on the first mile from the capture to the ingest node. Then there is a platform that does the chunking and the encoding, the re-encoding, the transcoding, the ABR, all that things into HLS, and at which point HLS is used for the delivery side of things, right? If that's the case, it would be very interesting to narrow the scope down to that first mile, because we're not in a P2P mode anymore, but we're on a client to server use case. And that's a difference that is being increasingly made in the past 2 years, I think, in the scope of the web transport discussion, in the scope of H3 discussion for the delivery, because there is a lot of mechanism with respect to NAT traversal and firewall traversal that can be simplified or completely removed from the discussion if you're in a C2S use case. My advice, my feeling is that it's better to put it in that scope to have a fair comparison. Again, if anybody thinks that's not the case, or as an argument against, or is interested in testing it in another use case, let me know. I'll put it in the list. There were last week some quick transport hackathon ongoing. I don't have the result yet because everybody that was at the hackathon is attending IETF. There were some new announcements with respect to web transport as well, with Will Lowe, the chief architect of Akamai, becoming the chair of the W3C group of web transport. Web transport will have a W3C and IETF group. And so there is a lot of things that show that CDN, web, and internet interests are starting to get together and speaking together on this topic. It would be maybe interesting to wait a little bit to see the result of that hackathon and the discussion that happened this week at IETF108 before we decide exactly what we're going to do with these tests. So my gut feeling, it looks like SRT will not be a full media transport. To to be discussed, given the definition I gave, even though it can transport media. It has some advantage over RTMP, but those advantages might overlap with existing functionality in RTP or QUIC for that matter. I think that was the result that Magnus' comment last time, is that the overlap with QUIC is big, and we need to take a look at that as well. But it doesn't mean it's not an interesting discussion, and it looks like there is a real usage in the first mile capture to ingest, and if even only in that use case, it would be interesting to spend time to get some data and compare with the other protocol used. And apparently RTMP is really the good comparison, because that's what being used for ingest in most of the live platform, as far as I can tell today. Slight question, anybody knows if 109 will be in Bangkok or online?
We don't know yet.
The decision's not been made, and we're at time for this agenda item. The agenda item that I thought we were going to have was a discussion of, we were going to, following on discussion a month or so ago on the mailing list about comparing different transport protocols and how crappy the comparisons are, that we were actually going to do our own effort where different people could participate instead of just building, instead of having arguments over personal perspectives and or gut feelings about things. So I think that we need to, you can send the slides to the list. We will post them to the meeting materials. The discussion ongoing is still, what are we going to do in a hackathon in order to actually do some of this work? Because I do think it is actually worth doing the work of figuring out how to talk about different protocols for transport of video and media, pursuant to the agenda item we just had a moment ago. So yes, I think that please send your slides to the list, because there's a lot of material to sort of dive into that, and let's focus as a whole on how do we move forward to do some actual testing. Does that make sense?
I agree, it makes sense, but before we start testing, I mean, we need to define the scope and what we're trying to achieve. So all those slides were about, can we narrow the scope to a few protocols that are really comparable and for a use case we actually interested in? And I left everything open there because I really don't have the answer about what you want.
Then it'll be a great list discussion.
I agree.
All right, thanks. And now we are past time. I have to shut this down because we are past time for the meeting, and we do have an AOB who did send in some slides, so I would really like to at least get that aired slightly. So moving on to the next presenter. Thank you. Kyle, do you have the slides?
No, I didn't see them in the meeting materials.
You should do. They were there.
Maybe I just missed it.
Yes, it's the first one on the list. Media operations use case for augmented reality application.
Got it. I will have it up in 1 second. And oops, wrong one. Okay, there we go.
Good. And do we have a presenter? Renan. Not seeing him in the list. Oh,
well,
yes,
maybe
yes, ask to send audio. There you go.
Oh, okay, it's at the top.
There you go. And we are, and I will preface this by saying we are going to lose our connection in something less than 5 minutes. So, that's odd. I keep saying accepting send. I'm going to stop touching buttons. Kyle, could you please say yes to Renan?
Yep, Renan, can you? He keeps appearing and disappearing.
This has been a common. I've seen this before, and it seems to be a permission problem. usually on the sender side.
Right.
On their side.
Yeah, they allow the
Yeah,
microphone
okay.
of media to be sending, and
Oh yeah, maybe they didn't do the accessibility, the change in the accessibility system prefs. Okay, we won't have enough time for him to resolve that before
Yeah. Before we get the hook.
before we
The
get
big
kicked
hook.
off. Yep. So we should consider this as a topic for an upcoming interim.
Yes. And with apologies for the technical glitches. All right. Interim Ho. Any other comments before we close or are closed?
Anyone get into the queue? No?
Well, I will
Sounds
say,
like that's a wrap then.
yeah, I will say thank you to all of our presenters who put time and effort into bringing their topics to us today. And thank you to everyone for showing up. And for our next challenge, I hope we can get to a point where we can have a discussion, because this seems very, very quiet. All right. Thanks, everybody.
All right. Thanks. Goodbye.